Okay, if you got here, if a and b are odd integers, right? Integers mean whole numbers, can be positive and negative. So the odd integers such that 4 is a factor of a minus b, then 4 is not a factor of a plus b. Okay, so the odd integers, so 4 is a factor of a minus b, then 4 is not a factor of a plus b. That's true, right? So what we're going to do now is we're going to prove this by contradiction by assuming the opposite. Assume that 4 is a factor of a plus b. Okay, so we're going to assume the opposite. We're going to say, well, no, if a and b are odd integers here, so that this is true, okay, and then this actually is the fact, well, let's just assume, well, no, 4 is then a factor of a plus b, not the truth. Let's be assuming the opposite. It says then there exists an integer c such that a plus b equals 4c. Okay, so we've got that there, haven't we? You know, if you think about it, 4 is a factor of a plus b. If 4 is a factor of a plus b, that means a plus b is a multiple of 4. Okay, because 4 goes into it, because it's a factor, 4 goes into it. So you can write a plus b as a multiple of 4, 4c, and c is just like any constant, right? But again, a whole number, right? It would be a whole number. So that would be true. Okay, now, what I would do now is, you got this and you're wondering where can I go next, but if you look at this second line here, right, they've sort of established this, haven't they, that because 4 is a factor of a plus b, then you can write a plus b as a multiple of 4. If you look at the top line here, it says here a and b are odd integers such that 4 is a factor of a minus b. Okay, and that's true, right? That's accepted, right? That's where we go in. So we can say the same sort of thing here. We could say, look, since 4 is a factor of a minus b, okay, there exists a constant. Now we call it a different constant. Should we call it constant d? Yeah, constant d, because we don't want to call it the same. There exists a constant d such that a minus b equals 4d, yeah? Because 4 is a factor of a minus b, so d is your constant. So we've got this. So now we've got two equations. A plus b equals 4c. A minus b equals 4d. Okay? And we can play around with these, can't we? It's like simultaneous equations. Now I know we've got like we've got 4 unknowns, haven't we, actually? A, b, c, d, and we've only got two equations. So we're not necessarily going to work things out here, right? But we can play around with it. What if I add 1 and 2 together here? If I call this 1 and call this 2, add them. That becomes 2a. Okay. This then becomes 4c plus 4d, yeah? And I don't know what c and d are, but that's what it becomes. But of course the b's cancelled, don't they? B plus minus b is 0. But then watch what happens. A then becomes 4c plus 4d divided by 2. And if I work that out, that becomes, divide each term by 2. I get this. And then I can factorize, can't I? I can say a is 2 bracket c plus d. But hang on a minute. What's that saying about a? This implies a has a factor of what? 2. 2 times something. Can a have a factor of 2? This implies a is even. If it's got a factor of 2, it's even, isn't it? 2 goes into it, it's even. Can a be even? Look at the question. A and b are odd integers. So we've got a contradiction. Okay? By assuming all this up here, turns out to be a contradiction. A must be odd. Therefore, assumption is false.